वेलकम बैक टू ऑल माय डियर स्टूडेंट्स। मैं रोहित उमंग आप सबका स्वागत करता हूं। आई होप यू ऑल आर डूइंग वेल। इन द प्रीवियस क्लास पार्ट 19 वी हैव discussed about the resistivity and related problem of resistivity. Now in this class we are going to discuss about the more problem related to the resistivity. So here is the first question. In this question are saying about that a wire of resistance 4 ohm. Here is the given that one wire have resistance 4 ohm is redrawn. That means by pulling redrawn मतलब क्या इसे पुल किया गया. So it's double. दो इसका लेंथ पहले था, मान लिया suppose that initially have L length and after pulling it's become the 2L. Okay, so double its length initially L and after pulling it's become 12. And also so we know that area becomes, if initial area is the A, then after pulling double its length, its area becomes A by 2. Okay, so we all know the formula of resistance in the terms of resistivity, length and area, rho into L divided A. Okay, so this is the old resistance, but whenever after pulling it become double, then new resistance become the rho is the same initially and after pulling the wire, and length become 12 and area become A by 2. Okay, so these two is going to the upward in the numerator, so then rho in L divided A into 4. That means this is the value of the old resistance. Okay, so our new resistance become the 4R. Okay, but here is given that R is the resistance of the wire. Okay, so we can find the new resistance is equal to 4 multiply old resistance, that is the 4. That means the overall answer is the 16 ohm. I hope so. This question is not very complex. It is so simple. Okay, so one concept here is that whenever any wire by pulling it become double, then its area becomes A by 2, and after applying the resistance formula in the terms of resistivity, length and area, we can find the new resistance. Okay, move on the next question. Here is another question. A wire of radius 0.35 mm. So here given the radius of wire is equal to 0.35 mm. So it can be converted into the meter. 0.35 multiplied 10 to the power minus 3 meter. As you how we convert mm to meter, I hope so you all are able to understand. And also this meter is converted into the centimeter, then it's become 0.35 multiplied 10 to the power minus 1 centimeter. Then we can also say that this is the value gets in the centimeter, 35 multiplied 10 to the power minus 3 centimeter. Okay, so after getting converting the mm into centimeter, we can find easily. So that's I convert mm into the centimeter. Now move on the next given data. Here is the wire of radius 0.35 mm and also has a length of 2.2 centimeter. Okay, so we can also convert into the not need to convert into the meter or mm, because it's have the radius given in the form of the centimeter and also length in the form of the centimeter. Again, it is the made of a material of the specific resistance. That specific resistance is known as the, I have already told about that, resistivity. Okay, so now find the resistance. By applying the formula of resistance rho into L by A, we can put the value of resistivity, that is the specific resistance and resistivity both are the same things. So we can put here 1.4 multiplied 10 to the power minus 8 ohm multiply length. Length means what? Length means the here is the given 2.2. So we write here 2.2 divided area means we look at the wire, it is the cross section area like this. Okay, so it is the cross section area look like a circular in the circular form. So we find the circular pi r square by the formula. So pi r means what? R means 35 multiplied 10 to the power minus 3 centimeter, then 35 to the square, and also 10 to the power minus 6. Okay, so whenever we after solving this numerical, we get the value of 800 multiply 10 to the power minus 12 divided 10 to the power minus 6. So we can here is the final answer is 8 multiply 10 to the power minus 6 ohm. That is the also called the 8 micro ohm. Okay, this is the final answer of this question. So hope so in that question here is the complex part. Okay, so complex part means what? Calculation is the complex part, but don't fear about that to doing. So we try to be solve it, okay, by itself. And again, if you have any problem in solving this type of question, we can comment here, and I will do more about how it's solve it. Okay, so I hope so this question is also not very complex, it's so simple, because here is the radius given, and wire of length given, and also resistivity given. So it's thus by the simple, by using the formula we can find the easily how the resistance we get here. Okay, so move on the next question. So here is the question, question number 3. Two conductor x and y. I have a two conductor x and y, and of course section area have radius. In the radius means the plural form of radius in the form of 1:2. Okay, so here is given that r1 divided r2, that means 1/2, and also length in the ratio 1:3. Okay, so length is also given that L1 by L2, that means 1/3. Okay, so and after that resistivity in the also given, that means rho 1 rho 2 is divided 3/1. Okay, so here we find the resistance by using these types of given data. So I hope so now we can find the resistance. Okay, that means the r1 by r2. Then r1 by r2 is the formula like what? r1 by r2 means we can put the value of formula of resistance like rho 1 and L1 divided A1. Okay, also R2 we can put the value here rho 2, because two conductor x and y, so resistivity are the also different. L2 and A2 is here, we can place in the numerator. So here is the that we can we are given that L1 by L2, rho 1 by rho 2, but not about the A1 by A2. So A1 by A2 we can find by the this data. So R1 by R2 is the, we can write here also A1 by A2 means what? Pi R1 square divided by pi R2 square. Pi to pi we can cancel. So here is that this is also called the A1 by A2. So R1 square means 1k square, and R2 square, that is 2k square, that means the 4. That will be the final value of the A1 by A2 is equal to 1 by 4. Okay, though, so we can put here and get simply the ratio of R1 by R2. So now we put rho 1 by rho 2, that will be the 3/1. Okay, so we can here write 3/1, and also L1 by L2, L1 by L2 is 1/3, we can also write here 1/3, and also A1 by A2 is 1/4, so A1 by A2, that means the 4 goes to the numerator, so we can multiply 4/1 here. So finally 3 we can cancel 3/3, so that is the final value of R1 by R2 is equal to 4/1. That means the R1 by R2 are the final answer of question number 3 in the 4:1. So hope so this is the question. In that question more concept are here is that so all data are given, you know, only use the formula of resistance, but by the using this formula we can need a area, because all the data like row 1 by row 2, L1 by L2 are given here, but A1 by A2 is not mentioned here, so we can find A1 by A2 by the help of R1 by R2. So hope so these questions are very helpful for you. Let's move on the next question. In this question, temperature coefficient of resistance is okay. I hope so you are look a good okay. So temperature coefficient of resistance is 0.00125 per degree Celsius. Okay, and resistance of 300 degree Kelvin is 1 ohm. Then what will be the temperature in the 0 degree Kelvin? Okay, and when resistance becomes 2 ohm. Here is the question that finding the new what will the temperature. Okay, temperature in the 0 degree Kelvin, then 0 degree Kelvin, then the when the resistance becomes 2 ohm. Okay, here is the question that find the formula. We have already told about that. RT is equal to R naught into 1 plus temperature coefficient of resistance into change in the temperature. Okay, and one thing I mentioned here, here is the whenever the 1 ohm resistance and temperature is 300 degree Kelvin, that means ki whenever temperature final temperature is 1 ohm, and what is the value of R naught? Here is the note mentioned, and R naught and 1 plus what is the value of alpha? Alpha is the also no mention here. So alpha and what is the change in the delta T? Delta T is how we know about the delta T. Delta T matlab change in the temperature. Okay, so here we know that here is the 300 degree Kelvin. Okay, and starting from the per degree Celsius. So I hope so here is that I am looking that alpha is the this is the this is the value of temperature coefficient of resistance, that is the alpha. Sorry for that, alpha is the mention here. So we can find the value of delta T by the help of this data, because resistance and 300 degree Kelvin is 1 ohm. That means we can convert the 300 Kelvin into the 300 degree Kelvin into the Celsius, that is the 20 degree Celsius. So here we write 27. Okay, and also what will be the temperature in the 0 degree Kelvin when it's become 2 ohm. Okay, so 2 and is equal to R naught and 1 plus 1 plus alpha into delta T. Okay, I have not mentioned here what is the value of delta T here. So we can find delta T by the help of this formula. So one here is that we can divide. Okay, by dividing we eliminate R naught. Okay, say our final value is the 1 by 2 that will equal to the 1 plus 27 into alpha and 1 plus alpha into delta T. Okay, so here is the again we can by multiplying cross multiply we will get the value 1 plus alpha into delta T. Okay, and is equal to 2 multiply 1 2 plus 54 alpha. Okay, so again we can here by applying the transposition method, we can alpha into delta T, we get 1 plus 54 alpha. Okay, 2 minus 1, that is the 1, and 54 into alpha. Okay, so here delta T we can also find 1 plus 54 alpha by alpha. Okay, so here we 1 by alpha plus 54. Okay, so now we can find the value of 1 by alpha and 1 by alpha by the this value. Okay, so we can eliminate 0.0125, that is the I hope so 1 by alpha and 125, and we can 1 2 3 4 5 10 to the power 5. Okay, 10 to the 5 is go to the upper side, So we can, when after 3 4, so after dividing we get, I hope so, it is the 800. Okay, so here we can put the value of alpha 1 by alpha 800. So here the final value delta t is equal to 800 plus 54, that is the 854, okay, degree Celsius. That is the change in the temperature. So we can know that the change in temperature is the final temperature minus initial temperature, that is the 854. And here is given that initially we can take the value of 0, so we can take final value is the 854 degree Celsius. That is the final value of temperature when the temperature becomes 2 ohm. Okay, so in this question something have going to be little bit complex, but after again we can repeat. And first of all, be careful about the data which are given in the numerical. Let me check again. Temperature coefficient of resistance, that is the alpha. Okay, and this value is going into the decimal, but don't confuse about that. In the decimal we can by simply calculation we can change in the 1 by alpha value is the 800 and per degree Celsius. Okay, and again resistance of 300 at 300 degree Kelvin is 1 ohm. Okay, then what will be the temperature in the 0 degree Kelvin when the resistance becomes 2 ohm. Okay, so here is saying about that we are the two type of resistance are given, 1 ohm and 2 ohm. And also whenever the 1 ohm resistance, its temperature is the 300 Kelvin, that is the final. Okay, so and what will be the temperature whenever the resistance become 2 ohm, we can simply find the final temperature whenever the temperature becomes 2 ohm by the formula of relation between the temperature and relation between the initial resistance and final resistance. Okay, whenever the resistance at 0 degree and resistance at t degree pe. Okay, so we can by dividing we get the final answer is final 854 degree Celsius. Hope so you have no doubt about this question. Whenever if you have a question, if you have any doubt in this question, we can again comment here, so I can again try to solve in the another way, and watch repeat and repeat again. So let's move on the next question. This is the another type of question. So look at the figure and find the value of given from the given with the help of given data. So here is the question: find the amount of current, okay, drawn from the battery when a copper block is connected. This is the copper block given in the figure through as shown in the figure, and the resistivity of copper is the 1 ohm meter. Okay, look at the figure. In the two figure A and B, first is the given that the block are placed horizontally and again is the vertically. So we can point out that type of placing a copper plate, because in whenever talk about A, in this given data like resistivity of copper is 1 ohm meter. Resistivity of copper is the 1 ohm meter, and also here is given that voltage, that is the 60 volt. We can apply the 16 volt, that means the voltage equal to the I1. Let me suppose I1 current are flow through this circuit, so I1 and R1. Okay, so I have R1 is what? R1 is here is not mentioned in this question, so we can find the value of R1 by the help of formula resistivity into length divided by area. Okay, resistivity means O, multiply length means what? Length means we can put here by 1 meter. Okay, whenever current are flow through this this copper plate, we go through the length of L. Now 1 meter and divided by area we can find only this area, because okay, so this is the important things we have consider here. Okay, so area is the pi r square, so we can put the value of pi. Okay, and pi multiply area. What is the radius here? Area means we can, sorry, don't use the formula here, pi r square, because it is the look like a cube. Okay, so we can find the area by the length multiply breadth. So 0.25 multiply 0.25. Okay, so after eliminating some point here, we can get the value of, I hope so, 16. Okay, 16 is the resistance R1 for this circuit. So we can find the current in the figure A. I1 is equal to what? 16 divided by R1, that is the 16 by 60, यानी कि 1 meter. Okay, 1 ampere, sorry. So I hope so कि in the figure we can find easily. Only we have considered about the portion which are connected with the wire. Okay, so area is not using like pi r square, because this is not a circular wire. Okay, it's the it here look like a cube type. So we can here by using formula of radius, we can find a radius here, and also by I1 we can find the by help of the formula V is equal to IR1 I1. Okay, so it is so simple things. I hope so you are able to understand. And in the last part, okay, B is the here mentioned here. I hope so this is the length of the 1 meter. Okay, and this copper wire is the same here, also placed, so we can 0.25 here and 0.25 here. Okay, so also we can find the resistivity R2, rho into L by area, that is the rho means 1, and length means what? Length means 0.5. Okay, because current are go from this by the only 0.25 divided by area means what? Area means 1 multiply 0.25. I hope so understanding that why we take 0.25 multiply 1. This is the length, and this is the breadth. Okay, so here we cancel, we can get the value of resistance is the 1 ohm. So we can find easily I2 equal to B, that is the 60 divided by 1, यानी कि 60 ampere. Okay, so hope so this type of question will helpful to clear your all concept here. So for the today class, this is the last question for you, and this video is going to too long. So today I will end of the session here. Thank you so much to all who joining here, and hope so you all enjoying my class. So if you are first on this channel, so please subscribe my channel and share this video for those people, those students which are get in class 9 or 10th 11 12. For the further update we can put more video here. Okay, related to the education video, like motivation video. So keep going, keep doing. You are the future. Thank you so much.